Hello, good morning, good afternoon or good evening. Welcome to lesson 12, okay, Programming Languages, part 1. In the previous lesson we looked at the ASCII table, quite useful, quite interesting that. Today, Programming Languages, okay. So, do we have a lead in? Yes, we do. Okay, so why do we need programming languages? Why do we need to have so many different programming languages? Okay, so I want you to stop the video. I want you to think about those two questions. I want you to use Google to help you answer those questions. Pause the video. When we come back, we'll talk about the answers together. Okay, go. So, why do we need programming languages? Well, because computers only understand ones and zeros. Machine code. Yeah, they don't understand English or Turkish or French or Chinese or anything. Yeah. So programming languages are this conduit, this interface between us and the computer. Why do we have so many different programming languages? Why do we have so many different pairs of shoes? Yeah, different shoes for different occasions, different clothes for different occasions, different meals for different occasions, okay? Different programming languages for different occasions. Sometimes you want something that does the job nice and quick, no bells, no whistles, no singing, no dancing. We've got a programming language for that. Other times you need something that gives you a bit more control. There's a programming language for that. Okay, so different programming languages for different tasks. And of course, there are many different uses for programming languages. Yes, we've got interfacing onto the web, interfacing to databases, interfacing to other pieces of external hardware. Yeah, so different programming languages can help us glue all of that together. So, quite a lot for you to read today, but we're going to look at these first few sentences together. Okay, so there are two ways to execute a program. We can interpret a program, or we can compile a program. Yeah, and we look at this in more detail in the next lesson, in part 2. But before we get on and we read all about it, I want to explain this a little bit. Okay, so when we interpret code, so here, yeah, I've got some code here. This is a Perl script, interpreter.pl. Yeah. When we interpret some code, the interpreter, which is the program running the code, reads this code line by line. Okay, so it reads this, interprets this, reads this, interprets this, reads this, interprets this. And line by line it transforms it to ones and zeros, to machine code, and passes that to the CPU, to the central processing unit, to be processed. This is in contrast to when we compile code. Yeah, so when we compile code, all of the code is read at once, it's all transformed into machine code, and then we get this output, we get this executable file. Yeah, this .exe file. If you're using Windows, most of you are probably using Windows, you might have seen these exe files. These are executable files that have been compiled by a compiler. Right? So that's a very simple introduction. Read the paragraphs. We will come back to these two concepts shortly. Okay, so now I want you to read the few paragraphs. It's quite long. Skim the text, fill in the timeline, and can you identify the years when these programming languages were created? Okay, so using this text, can you do these two tasks? Again, pause the video and come back, and we will check together. Okay. Okay, so compiled languages. we found these three: C, C++, Pascal. Interpreted, Perl, PHP, JavaScript. Unsure, basic, it doesn't tell us. No, it doesn't tell us. Java and C#, these are a bit 50-50. They're kind of compiled and kind of interpreted. Yeah, they're compiled to bytecode, and then that bytecode is interpreted. So it's a bit iffy. And assembly language, we can see from this graphic, wherever it is, assembly language is assembled using an assembler. Yeah. So for high-level languages, we use a compiler or an interpreter. For low-level languages like assembly language, we use an assembler. Yeah. And whether we use a compiler or an interpreter is not our choice. If we use C, that is a compiled language. It is not an interpreted language. If we use Perl, that is an interpreted language. It is not a compiled language. Okay, so we cannot choose whether we compile code or whether we interpret code. In the next lesson, there's an example of compilation and interpretation. But today it's important that we start to understand these concepts. Now here's the timeline. Perl 1980s, I think, is correct. And there's lots of new programming languages. Yeah, so when we come down here, use the internet to add more examples. You can find many more examples of programming languages. Okay, well let's do that now then. Yeah, so read the text again more carefully. Use the internet to add more examples. Okay, we don't need the text for this task, but use the internet to add more examples here. Underline the function or the use of each programming language in the text. Okay, so for example, here, what's the function, what's the use? Here, it was created to teach programming. That's the function, that's the use of BASIC. Yeah? So for each of the other ones, can you identify a sentence similar to this that tells you the function or the use? When or why is a compiler better than an interpreter? When, why is an interpreter better than a compiler? What is a disadvantage and an advantage of assembly language? Okay. Alright, so again, pause the video. When you're ready to check your answers to these, come back and we will check together. Okay. Right, okay, so we're not going to check the answers for these. There are so many programming languages. I'm going to assume that if you got these from the internet, that your answers are correct. Underline the function, the use of each language. So where's my answers document? This is the same answers document that you have that's on Schoology. So assembly language is used where RAM is limited or time critical code is needed. Okay, so if we need something super fast, super lean, L-E-A-N, then we need assembly language. Yeah, a lot of our operating system, a lot of the key core components of the operating system are written in assembly language because they need to be super fast. Yeah, they need to take up as little memory as possible, and they need to be super fast. So things like device drivers for your sound card or for your video card. If you play a lot of games, the core components of those games will be written in assembly language because they're very fast. Yeah. So C is a general purpose tool. And here, there's a hint here, systems programming. Okay, so a lot of the systems are programmed using C. C is not such a high-level language, so we have a great deal of flexibility with it, so it's useful for systems programming. Perl, quick and dirty programming. I'll show you this example of a very simple Perl script ever so shortly. So if we need a quick and dirty solution, Perl is a good candidate. PHP for web servers, Pascal is a teaching language. C++ is used to create power-hungry applications that need to be fast. Yeah. C# is used to create all sorts of things: desktop applications, games, web applications, mobile development too. So all sorts of things for C#. JavaScript used in browsers, and BASIC, as we looked at the start, used to teach programming. Yeah. Okay, so when is a compiler better than an interpreter? Now, the answer to this question is not explicit in these pages of text. Yeah, we've got a diagram here about an interpreter or a compiler. We've got some information here about compiling. So let's revisit this. Yeah, so let me go back to the black and white version. Some languages need to be transformed, the transformation compilation. It needs a build step. You rebuild it each time you make a change. So that's probably a disadvantage, yeah? You make an ever so small change, you need to rebuild your whole program. Now your whole program might be dozens of source files, yeah? So rebuilding each time, even on very fast computers, can take a couple of minutes. And if you have to rebuild every 2 minutes, and your compilation takes 3 or 4 minutes, then it's quite a disadvantage. But to go back to the question, so when is a compiler better than an interpreter? Well, have a look at this example. Okay, so this is a Perl script. Let me change my theme so that I become a bit brighter. There we go. Okay, so this is a very simple Perl script. And this is all it does. Press enter to continue. We press enter, it finishes. Okay, super, no problems, yeah? Super simple, super simple. Now, if we were to compile this program, we would get an error. And we would get an error because of this line here. We try to divide by 0. Yeah, you can't do that. You can't do that. Your computer will blow up, there'll be smoke, you'll get a knock on the door, there's all sorts of trouble if you try to divide by 0. Yeah? So if this was a C program or C++ script, piece of code, and if we tried to compile it wouldn't compile, because the compiler would identify this line as a problem, it would throw us an error, and we would have to fix that error before we could send that product to our customer. But interpreted languages are different. Interpreted, we understand, they read line by line. Yeah? So the interpreter never gets here. Yeah? So press enter to continue. So let's do it again. Yeah? So we press enter to continue, finished, success. Yeah? We get down here, finished, success, no problem. But if we don't press enter to continue, if we press Q, then we get an error and our program dies. Yeah? Illegal division by 0 at line 15. Yeah? Here we go, at line 15. So this is a key difference between interpretation and compilation. Yeah? When we compile, this sort of problem is picked up by the compiler. But with an interpreter, this problem is only picked up at runtime. Yeah, and that's key. Let's say we send this to our customer, and our customer tries it once, and they're happy. Yeah, no problem. They pay us the money that they pay us. Yeah, but then another customer tries it, and they don't press enter, they press Q. Well, that's something that we should have picked up when we were designing it, when we were testing it, but for whatever reason we didn't, and the customer sees that the program has died unexpectedly. Yeah. Now this is quite embarrassing for us, and it's a problem for the customer. Yeah, because the customer expects us to have tested this software properly. So, why does it keep doing that? So a compiler is better than an interpreter in that it tests all of they're called execution paths. Tests all of these execution paths at build time. Yeah? An interpreter, when is an interpreter better? It's faster. Yeah, we don't have to hit build each time. So it's a kind of trade-off. If your build takes a long time, using an interpreted language can be easier, can be quicker. Yeah. In the long run, a compiler is probably quicker. Yeah, even with the long build times. But we're going to get into this issue more in the next lesson. But it's important to kind of start understanding the difference. And if before the next lesson you want to Google the difference between a compiler and an interpreter, that would be useful. Yeah? An advantage and a disadvantage of assembly language. Well, we have this video here. Here it is. Let me shift me out of the way. What's important is that there is actually a mistake here. This is not comparing C to machine language. Machine language is just ones and zeros. This is comparing C to assembly language. Yeah, so we can see the assembly language here. This is quite a nice, quite a useful video. It's only 10 minutes long, so I recommend that you spend 10 minutes watching this, and then try to identify some pros and some cons. Some pros, as we identified up here. Where time-critical code is needed, so assembly language is very, very fast, and it's very lean, yes, where it doesn't need a lot of memory. Disadvantages, well, look at it. Yeah, where is it? Where is it? Look at it. I mean, imagine trying to write that. That is what you have to write. Yeah, disgraceful. Yeah? But if you can do it, there's a lot of money to be made still in writing assembly language. Okay, so let's talk about Java. Before you listen, I want you to look at it. I want you to identify any difficult vocab and try to predict some of the missing vocab. Okay, pause the video, read it, try to predict, come back, and we will listen. We will listen together. Okay. Okay, we're going to listen together and try to complete the blanks.
Unit 25, Task 3. Now used on millions of web pages. The idea for Java started in 1990 when a team of software engineers at Sun Microsystems decided to create a language for a handheld device that could control and interact with various kinds of electronic appliances, ranging from Nintendo Game Boys to VCRs and TV set-top boxes. They developed an object-oriented programming language that one of the engineers, James Gosling, called Oak, after the tree outside his window. The device even had an animated character named Duke, who would go on to become Java's mascot. With the advent of the web in 1993, the company made a web browser based on the Oak language. Later on, this language was adapted to the internet and renamed Java. The 1.0 version of Java was officially introduced by Sun in May 1995. At that time, web pages could only display text, pictures, and hyperlinks. With the arrival of Java, web designers were able to include animation and interactive programs on web pages. The first major application created with Java was the HotJava browser. The Java language began to attract serious attention from the Internet community and was soon supported by Netscape Navigator and MS Internet Explorer. Today, Java is a hot technology that runs on multiple platforms, including smart cards, embedded devices, mobile phones, and computers.
Okay, if you need to listen to that again, rewind this video and listen again. The answers are in your answers booklet. Here are all answers. Okay, so decided to create, they developed, called Oak, even had, based on the Oak language, renamed Java, web pages could only display, web designers were able to, the Java language began to attract, and number 10 was soon supported by, and the last one, mobile phones. Nothing too difficult there, I think, yeah? And a nice, simple, gentle introduction into Java. Well, that's some information about Java. Now let's have a look at an example of Java code, yeah? And this is Java code that works. You can copy this from your booklet, put this into a Java file, and it will run on your computer. We will run it in the next lesson. What I want you to do for the remainder of this lesson, have a look at the code. There are 3 tasks. What does this do? Okay, so we've got some code here. What do you think that does? Here, what do you think that does? And here, what do you think that does? Okay, so a bit of homework, and we will use these 3 examples in lesson 12 when we come to look at different types of loops. Okay, so this is useful for the next lesson. And that's lesson 11. Yeah, so I'm going to leave that with you, and we will pick this up at the start of the next lesson. If you have any problems, any comments, leave a comment in the video, in the comment video, and then I can reply to that comment and give you all the help you need. Okay, bye for now.